Ladies and gentlemen, my name is Lukas Makevicius. I'm a research assistant at the Institute for Metal and Lightweight Structures of the University of Duisburg-Essen in Germany. Today I would like to give you an insight into the main properties of Duroplastic gap-filling materials with regard to their application in preloaded bolted connections. This presentation is based on the test results from the German cooperation project entitled Development of a Material Model and a Design Concept for Gap Compensation Materials. This research project is currently carried out by the Institute for Metal and Lightweight Structures of the University of Duisburg-Essen and our partner company Duroplasty GmbH in Mönchengladbach, Germany. I would like to start the presentation with a short introduction, which will be followed by a brief description of the experimental investigations that are currently carried out in the project. The test results will be presented, discussed, summarized, and finally a short outlook will be given in order to give you a brief idea of what you can expect from this research project over the course of the next year. In steel structures, bolted connections are preloaded either for load-bearing capacity reasons or for serviceability reasons, for example, in order to minimize slip and deformations. Independent of the technical competence and the appropriate equipment resources on the construction side, production and assembly-related imperfections might not be excluded and can therefore result in a formation of gaps between the steel parts. The European standard EN1090 Part 2 allows an edge offset of 1 mm in case of preloaded bolted connections. Our investigations in terms of other research projects into load-bearing behavior of slip-resistant connections under consideration of various imperfections show that 1 mm gap might result in 20% lower slip factors and should therefore be avoided in order to guarantee the safety but also the efficiency of the connection. In general, those gaps are usually covered by packing plates, but in cases where gap cannot be completely covered, or especially in applications where closer contact may be required in order to avoid the cavity corrosion, it is possible to use gap-filling materials, also known as liquid shim. Surprisingly, the idea of composite bolted connections and their implementation into real bridge construction were carried out in the early 60s. Since then, a few systematic investigations were carried out with the aim of increasing the static load-bearing capacity and showed a great potential not only for the compensation of gaps in general, but also for the application of gap-filling materials in preloaded bolted connections. One of the main questions in terms of our research project is, are Duroplastic gap-filling materials suitable for their application in preloaded bolted connections regarding especially the creep sensitivity? In order to answer this question, systematic investigations into preloaded bolted connections with two-component reaction resin system, the MM1018 of the company Duroplasty GmbH, are currently carried out. The main focus in terms of these investigations lies on the determination of the slip factor according to EN1090 Part 2 Annex G, under consideration of a slight modification of test specimens as can be seen on the right. Furthermore, relaxation tests on an 8-bolt test specimens were carried out in order to determine preload losses due to setting effects in creep or relaxation. In terms of the slip factor test, several variables such as the application type, here liquid or pasty type of the material MM1018, gap thicknesses of 2 mm, 5 mm and 10 mm, as well as curing time and application temperature have been defined and will be investigated over the course of the project. Also, two different surface conditions were considered: grid-blasted surface condition and grid-blasted surfaces with alkali zinc silicate coating. The reference specimen configuration for the slip factor test as well as the relaxation test has been set to 2 mm gap thickness, 24-hour curing time at room temperature and grid-blasted surface condition. One of the most important matters in the project was to guarantee the reproducibility of the application process and, of course, the adjustment of the desired thickness of the gap-filling material in the connection. For this reason, a special adapter unit has been designed and verified in terms of the pre-investigations. As can be seen in the pictures below, it was decided to create special openings with threads and to inject both materials, the MM1018P, the pasty version, and MM1018FL, the liquid version, manually using cartridges and applicator guns. Furthermore, special pins were created in order to guarantee a minimum clearance hole of 17.6 millimeters. The pre-investigations confirmed the flawless filling of the gaps. Also, no surface voids could be identified after the curing of the material, so that the same procedure, including of course the adapter units, were applied to the actual steel specimens for further testing. The results of the slip factor test are graphically summarized in the chart on the right. The static slip test carried out on the reference configuration showed that the slip factors mu-ini mean, considering the initial preload when the test started, are comparable with 0.78 and 0.8 for the liquid and pasty material respectively. It must be mentioned though that consideration of the actual preload at slip in form of a slip factor mu actual mean shows higher creep sensitivity for the pasty material in comparison with the liquid type of MM1018. The first comparative studies considering the static slip test confirmed that compressive strength of both material types seems to be fully developed after 24 hours. It can be seen though that an alternative surface condition, here grid blasted surfaces with alkali zinc silicate coating, leads to around 16 to 18% lower static slip factors. First investigations into variation of application temperature indicate that higher ambient temperature does not affect the filling process or curing of the liquid type of MM1018. Finally, the first extended creep test showed that slip factors of more than 0.4 can be achieved by using the liquid type of the gap filling material MM1018 for the investigated surface treatments. This corresponds to class of friction surface B according to Eurocode 3 Part 1.8 or the EN 1090 Part 2. The pasty type of MM1018 leads to lower slip factors of 0.33 and 0.39, which can be addressed to a higher creep sensitivity of the material. These results comply with the class of friction surface C according to the standards that I mentioned before. In terms of the first relaxation test, the tightening was carried out up to the minimum nominal preload value FBC of around 110 kilonewtons for M16H3 bolting assemblies. The resulting preload losses were then measured for 30 days and extrapolated to the intended service life of 50 years, as can be seen in the diagram on the right. The mean preload losses after 30 days and 50 years averaged to 15.3% and 22.3% respectively. For the next step, the same specimens were retightened to the same preload level of FBC, which resulted in about 60% lower preload losses after the extrapolation to 50 years of around 9%. So, the first investigations into preload losses of Duroplastic gap filling material MM1018FL, the liquid version, showed that the preload losses due to setting effects and creep remain within 30% and indicate its potential for the use in preloaded bolted connections. While the suitability in bolted connections of categories A and D that are preloaded for serviceability reasons is quite obvious, it also might be possible to use the MM1018FL in preloaded tension connections of category E. However, this would require high system reserves that might be achieved, for example, by using the combined method according to EN 1090 Part 2. In case of slip-resistant connections, preload losses due to setting effects and creep are generally covered by the extended creep test, so the question of suitability of the gap-filling materials in these connections can be directly addressed to the desired slip factor in the connection. As mentioned before, the formation of gaps between the steel parts might be possible due to production and assembly related imperfections. Beside the use of packing plates, gap-filling materials provide an alternative for gap compensation. In order to investigate the suitability of gap-filling materials for their application in preloaded bolted connections, German cooperation project Duroplasty is currently carried out on a two-component reaction resin system MM1018. The conducted slip factor test showed that the liquid material type of MM1018 leads to slip factors of more than 0.4 and the pasty type to slip factors of around 0.3. It must be mentioned that these slip factors implicitly cover main preload losses due to setting effects and creep. Furthermore, first relaxation tests on the liquid type of the gap-filling material MM1018 showed that preload losses remain within 30% after their extrapolation to the intended service life of the structures. This indicates that the application of the gap-filling materials might also be possible in preloaded tension connections of category E, as long as high system reserves due to tightening procedure can be ensured. The observed results provide an insight into the main properties of Duroplastic gap-filling materials with regards to their application in preloaded bolted connections. Further experimental investigations, including slip factor tests, relaxation tests, as well as compression tests and tensile tests, are currently carried out. Based on these test results, development of a material model, including numerical investigations, are intended. We wish to thank the Federal Ministry of Economic Affairs and Energy for funding this research project. Thank you very much for your attention, and in case of any questions, please do not hesitate to contact us. Thank you.